Good afternoon, everyone. Welcome to the PARC Forum. Good afternoon, everyone. Welcome to the PARC Forum. I'm Chris Hibbert, the host of this series of forums sponsored by the System Concepts Lab. This week's forum is open. Next week's forum will also be open. That's one you won't want to miss. It's on a project called the Alternate Reality Kit, done by Randy Smith of the System Concepts Lab. Excuse me, fumble mouth here. This week's speaker is Frank Halasz, who's going to talk about Notecards. Frank got his PhD in cognitive psychology from Xerox PARC University in association with Stanford. His dissertation topic was on roles of mental models in using calculators. He joined PARC for real right after he got his PhD in January of '84. He's worked on Notecards since then and hung out at PARC. His interests are human-computer interaction, and it says hacking here. Here's Frank.
What I'm going to talk about is what is Notecards and why have we built it, so give you some rationalization, and then I'm going to say, is in fact the system that we built useful for what we set out to do, and then finally I'm going to say what research does this assessment of the system suggest. Okay, so here's a outline done the right way in Notecards of the talk. I'll start out with a little background about idea processing and what design considerations that suggested to us. I'll give a demo of the Notecard system, talk about some programmer's interface. Then I'm going to talk about Notecards in use and what applications it's been put to. And finally, I'm going to do assessment along four dimensions of Notecards. And so that's a high-level overview of the talk. Notecards is the outgrowth of a government contract. We start out with a very specific task to support. And that's the task of an information analyst. And basically, we wanted to support people who sit there all day and basically gather information. Their task is to, read newspapers and intelligence reports and what have you, and produce analytic reports, either at regular intervals or when somebody says, come in and tell me what the Mexican bank's going to do next year. So they have this general procedure. They read sources, they collect clippings, and actually the people we're supporting actually file them in physical shoeboxes to a great extent. And then they write analytical reports. Now, if you talk to any of these people, there's a very critical observation. Everybody says, yes, we go through this procedure, but the real critical aspect of this task is the models and concepts and analyses we're forming in our heads while we do the task, while we read our clippings and while we think about what reports we want to write. Okay, so there's kind of a research goal, which was to develop a technology to better help these people do their tasks better. And basically, by looking at that critical observation, we came across the notion that what you want to do is help people form better conceptual models and analyses, and better expressions of these conceptual analyses and models. If they're forming a model in their head, they want to express it better in these reports that they write. Of course, this begs a really interesting question. Probably the most interesting question in the whole project is, what is a better analysis? But being good computer scientists, we're just throwing that off to the wayside and said, whatever a better expression or better conceptual model is, we're going to build a tool to help you do that. Why is this interesting project to pick up at a place like PARC? Well, there's a general interest here in building systems that help or support intellectual work, and this is a prototypical task of intellectual work, is sitting there collecting information and writing articles on it. So it seemed like a good test domain to work in. So we started out with a very basic approach, which is not too surprising, and that is what the computer was going to do for people, for these analysts, was to reify their ideas. It was going to take their ideas out of their head and represent them somehow in the computer and on the screen. Very common thing in computer science these days, especially in AI. And since we're members of the Intelligent Systems Laboratory, our next question was what to do next. Were we going to build an AI system or not? And in fact, in the project that preceded Notecards on this same basic line of research, they took an AI approach. They were going to build an expert system that aids or checks or advises the creation and application of analyses and models that these analysts are doing. The notion was to build a strong representation language plus some sort of inference engine, and that was going to help these analysts do their task. They didn't get very far on that because I don't think they understood the first thing about the analyst task. They didn't know what a better model was, so they couldn't build an expert system to help build those models. We took a very different approach, Tom Moran and I, when we took over the project, which was the hand tools approach. And Tom has this great motto, which is that intellectual work is a handcraft that basically can't be automated. If you can automate it, it's no longer intellectual work. So the whole approach that we took had really three parts. The first one was that information management is really the big problem. I mean, my God, these people are clipping things and putting them in shoe boxes. We could at least give them information management tools to store this stuff electronically. Secondly, we were going to build them tools to help manipulate and explore weak representations of their ideas and analyses. We weren't going to require them to put this stuff in the nice, clone networks or any very precise representation, but they can just dump their ideas somehow onto the machine. Doesn't have to be machine processable. And then finally, the third part is that when we finally understand some of the tasks they want to do, we can automate those, okay? But the whole notion is on this hand tools approach. We are not going to automate the tasks these people are going to do. We're just going to help them along. Being psychologists, the first thing we did was sit down and think about the task a little bit. And we worked up, we used to call this the authoring model, but it was so vague and had so little empirical backing, we now call it the fast and loose authoring model to indicate that it has no empirical backing other than our sitting down and thinking about the task. We wanted to look at this task of authoring, which is kind of a general word we use for this notion of collecting ideas and writing reports. And we basically came out with a model that had, this is a simplified version, it had 5 stages, which were, actually on this slide, 6 stages, that were delineated by the kind of objects you were working on during those stages. So the notion is you start out by collecting sources. Either you look in document databases in books and Westlaw or Lexis or Dialog or what have you, or you sit down and dump ideas out of your head, you brainstorm. Once you have those sources, what you want to do is extract the notions, the ideas, the concepts in them. Once you have the concepts, you want to kind of figure out what the relationship among those concepts are. You want to figure out what the structure of those ideas is. And play with them. You want to build models, you want to build analyses, and so on. Once you have your idea structured or analyzed, figure out what the relationship is, you have to usually organize some sort of presentation, write an outline, figure out what the structure of your talk is, and so on. Finally, once you've got your presentation organized, you want to write the document, and then you have to produce the document. We also looked at tools available on the market for each of the stages of the authoring task, and it looks like it is the case that all of the emphasis has been down here at the latter end of the writing process in terms of producing the document, nice text formatters and so on, and in writing a document, producing words and sentences in terms of text editors and spelling checkers. You see, not in the kind of PC market, you see some of these outline processors, they call them idea processors, but they're really outline processors like Think Tank. But if you look up here in this range of extracting ideas and structuring your ideas, modeling your ideas, and so on, you don't see any computer tools on the market, and that's the hole that we hope to fill with Notecards. In fact, let me say, what we hoped to do with Notecards was solve the whole task, an integrated system that went throughout the entire authoring process, but this was the hole that had to be filled for which we had no other models. So we took that fast and loose authoring model, and it suggested to us, loosely or strongly, some design principles for the system we were about to build. The first one that came up was that this whole, when you're working with ideas, you're working with idea-sized units. And we came across this notion of ideas about as much information as fits on a 3x5 note card. I think I got that from my 3rd grade teacher, and this is the first time it's ever been useful. But we built it into the system. It's a good metaphor to start with. We also had the notion that your ideas have to be represented in many ways, both formal and informal. So you want to be able to allow people to dump text or graphics just free text, free graphics, and so on. But you also want to be able for them to represent things like procedures or frame-based languages and so on. So you want both formal and informal representations. Similarly, the relationship among ideas have to be represented in many ways, formal and informal. So the whole notion here is multiple representations and alternative representations of the ideas you're working with. Information management tools I already talked about. The big part of the problem of idea processing is dealing with lots and lots of information. I have a bias from working with Unix too much that classification hierarchies are a good natural organization. My two co-conspirators on this project violently disagree with that. But since I'm giving the talk, I put that in. Notion that we wanted the integrated environment for the entire authoring process, that is from collecting sources all the way to producing the documents. You want one system that helps you throughout the whole thing. And finally, a very important point. We had no idea what idea processing was about, really. Most people who start a task of writing a paper don't quite know what they're doing, and the task changes as they do their research project and write their paper. So we're dealing with kind of an unknown and inherently variable task. So the system that we built had to be adaptable. It had to be tailorable to different tasks and to different people in different projects as they changed and as the system moved around. So one of the big goals of this project is this notion of adaptability and extensibility. Let me now switch over here and do you have a picture on your screen there? I don't know. Does it say where's it? No. I can't see. There's nothing on my screen here. Yes, Don't shut it off.
No, I'm just playing with the brightness, and there's nothing on the screen.
Yeah, well, you see it, but I don't.
You may have to sit on this side.
Is there enough? Huh? All right, we're going to try this. Could someone perhaps call CMS to see if they could do something about this? Very entertaining because I want him to pull in onto the screen, and then I can't get any. What you see here in the middle of the screen is a note card, a little electronic generalization of a 3x5 note card. Every note card has an underlying editor of some sort. This happens to be an Intro SD text editor, standard Xerox point-and-type text editor with multiple fonts and so on. Let me take one step backwards and mention what I'm showing you here. Very early on in the project, we went out and hired Ken Allen, a history graduate student at Stanford, to come and use our system. We sort of dumped him in front of the system and said, write a paper. And he spent about 8 months with us writing that paper. And what I'm showing you today, many of you have seen this before, is the same old database. This is the database Ken created while researching and writing this paper. And I'm going to use it to demonstrate the system. The content I'm not very familiar with, but the form is. So this happens to be a note card on capabilities of new missiles. The interesting thing about it is down here at the bottom of the note card is a little icon of a note card, and if I press in that, it will bring up a related note card. So that icon represents a link between the capabilities of new missiles note card and the guidance of Pershing II note card. And you see that down here again at the bottom of the guidance of Pershing II note card is a link to another note card, which if I press, it'll reach in the database and pull up that note card, and so on. Down at the bottom is a third note card, cruise guidance system, and if I point in the link icon in that one, you'll see that it creates a cycle and goes back to guidance of Pershing II, which is already on the screen, so it just flashes them. So there we have the two basic concepts in note cards. We have this thing called a note card as some editable little substance, and then we have a link which connects two note cards. Now, all links are typed, so I can redisplay how this link is shown, and you see that there is a link type that Ken decided to call an unspecified link to this note card called Guidance of Pershing 2. The type is just a label that the user puts on in order to indicate what kind of relation exists between the two cards. Our dear user Ken here decided to use all unspecified and C-links, so we really didn't use the link typing mechanism to carry any information. So you won't see that in operation today to a great extent. Okay, basically, the first thing we did was actually present Ken with this system, which was basically a network of linked note cards. And he created 150 note cards, and he came into my office. This is probably apocryphal now that Ken's here, but came into my office and said, I'm lost in this network of 150 note cards. Help me with some context mechanisms to find my way around this network of note cards. So we basically created two different kinds of context mechanisms to help him deal with this large network of note cards. And could you pull back a little bit so I can see my screen and actually know where to move my mouse? Pull back all the way. I have to see to the bottom of the screen there. Okay. All right, you can pull back in here. The first thing we created was a thing called file boxes to mimic the shoe boxes our analysts were having. It's basically taken directly from the Unix directory structure. There's a file box is just a specialization of a note card, and inside a file box you file other note cards. Every note card in the system has to be filed in a file box somewhere, although they can be multiply filed. And file boxes, anyway, there's the file box hierarchy. So you see here there's a file box called US TNF missiles, and the note card we started with called capabilities of new missiles is actually filed in that file box. In addition, there's several other note cards plus two other file boxes. So if I press Pershing 2 characteristics, you see that I'll bring up a file box, sub-file box, which has no sub-file boxes of its own and a set of note cards.
You're doing all right. We're just going to leave on the front of the rest of the
You have to read, okay.
Well, I mean, we don't want to.
All right, I'm going to try to go through this. I'm a little discombobulated here, but I'm going to go through it this way. Okay, so we have these file boxes filed inside of file boxes. Basically what we have is two alternative organizations for all your information. We have this network of note cards that kind of captures the relation between the ideas captured in the note cards. And then we have this hierarchical filing structure that helps you find your way into a context in that network. So the basic idea is when you start your day, you kind of look through your file boxes till you find the file box on the topic that you happen to be interested in, and then you drop into the network of note cards and follow the links around. Now, whether that idea is a fiction or not, I'll talk about a little bit later. The second thing we provided for Ken in terms of a context mechanism, if I can see it, I got it, is a concept called a browser. Now, a browser is just a, could you pull back so I can see what I'm doing? Yeah, see, I messed up because I can't see anything. Let me just. Could you pull up? I can't see. Yes. How important is context in a system like this? A browser is a node and link diagram of the note cards network. So basically, you ask it to start at a particular note card and follow the links of a particular type through the network and draw you a picture of that. Now, in the original version, that picture was just a snapshot of the network. Later on, we put it in editing into the system so that you can actually edit. I must have, looks like I hit the wrong button. No, here we go. Well, that's real pretty. That's not at all what I meant to draw, so obviously I drew the wrong network, but this will be good enough for an explanation. You see that inside the browser is note cards are represented by link icons that with their title, and then the links between the note cards are represented by links in the browser. Now you can actually, I may be able to well, no. Okay, just don't move too much. There we go. You can actually edit this picture in order to help you work with it, or, and I daren't do that now, you can edit this diagram in order to edit the underlying structure. So you can actually structure your whole network from a browser by creating cards and creating links directly in the browser. And that will create cards and links in the underlying note file, which you can then later bring up and fill in and so on. Okay, usually I demonstrate that, but I won't in this case. Could you pull back so I can see what I'm doing? Thanks. Okay. So those are the four basic concepts in note cards. They're the note cards, the links between note cards, the file boxes for filing note cards, and the browsers to give you an overview of those, of the network. Let me just go quickly. You know, the other major bug here is that I can't see my clock in the corner of the screen anymore. I can imagine what our customers feel like. Could you go all the way back? Thank you. Let me just give you a brief overview of how Ken would use this system to take notes and file them away. What you see here is the top level of this file box hierarchy. And Ken used the top level of the file box hierarchy, the root box, as kind of a toolbox in which, could you pull up to that card? To this one here. Yeah, as a kind of a toolbox hierarchy, where a toolbox to keep the kind of things he was working on, the things that were relevant to what he was working on at that point. One of the things he kept in there was a file box called a bibliography file box. The bibliography file box, in the bibliography file box, Ken basically kept note cards which were bibliographic references to all the articles that he was reading. So if I point to the one that's called Newsweek October 22nd, all you see is a bibliographic reference to some Newsweek article he read while researching the paper. Let me go up here to Smith Deployment Shakes Politics, and we actually scanned in a few articles on the Kurzweil scanner in order to give us a feeling of how you'd use the system with electronic text, because that's what the system was designed to. So here we see an article from Science by a fellow named Jeffrey Smith, and this is going to be hard again, okay. And let me just scroll up in the text to a particular paragraph. Could you pull back so I can see my screen? Thanks. Now this article says, the interesting paragraph says, you can't read it, the Soviets complain and the Europeans widely believe that the Pershing II is intended primarily as a first strike weapon. Well, let's say that's an interesting paragraph and I want to take a note on it as part of my work. What I'm going to do is go over here. Now I could just type text into the new note card that I just created, blank text card. What I'm going to actually do is just copy that text over if I can. Very hard. So what I've done is created a new note card with some new text in it. Let me reshape that so we can hopefully see it a little better. The first thing I want to do is in reading this paragraph that I just took a note on, it reminds me of another note card that I took yesterday that it contains, let's say, some contradictory information. So my task is to find that other note card. So what I want to do is look through my note file to find the other note card that I'm reminded of. Now there are lots of ways to do that. I could look, for example, down through the file box hierarchy until I came across the note card that I was looking for. But in this case, I'm going to look in the index file box, which is just a hand index that Ken created to index some of his cards by keyword. And let me look under flexible response because that's where I think it's going to be. And I happen to know, aha, that's the card, missile gap question. So let me bring that up and put it next to, could you pull out so I could see the other card? Thank you. Put it next to the card that I was creating. Let me create a link between those two cards. So I go up here and say insert link. And the first thing it says is, what kind of link type do you want to create? And it gives me the list of all the links I've already used in the system. In this case, I don't see anything that indicates contradictory information. So let me just create a new type of link. So as you can see, the links have no semantics. The user can create them at will. It leads to some problems if you have programs that run over the network and process it, or if actually you're sharing a note file in what I call rebuttal, you call contradiction. So there have to be conventions for sharing note files or building note files are going to be machine processable. So what you see is I've created this link. Let me change the display here if I can. Could you move over so I could see the end of that? Thank you. Let me, so we can see the whole thing. You see there's a contradiction linked to missile-gap question. Now, whenever I bring up the new note card, I will have that, I'll know that there's related information that is contradictory, and I can follow that link and so on. Okay, let me put this away, and I may want to say, if I was actually using this, link it to other note cards that I think it's related to and start building some idea structures or whatnot. What I'm going to do now instead is just file it away. Let's say I'm done with it. In order to file it away, Ken usually kept on his screen, let me throw away the original here, a browser note, can I see? There we go. Okay, good enough. Could you pull all the way back so I can see this top of the screen? Thank you. What you see here is a browser of the file box hierarchy that Ken created while taking notes. So you see here it starts up here at the topics file box, which was the root of his file box hierarchy. And the topics file box has 5 sub boxes like US, TNF missiles, and so on down the line. So this is basically the organizational structure in which he was keeping his information. Now could you pull out so I can see that other card? Obviously I lost it. Amazing what you can do blind. So my task here is to file this note card away, and can anybody? I just sent it to. Could you pull back so I can see the browser? Thank you. Yes, very good. Looking through my file box hierarchy, I see that I can't see anything. Let's just pick an arbitrary node. This file box is a likely place to file this new note card. So what I want to do is go to the note card, if I can see anything, and designate a file box, and then I want to pick the file box one I call pick NATO US TNF doctrine. It actually belongs. Great. Hello. Would you pull back? Thank you. Very interesting. That is actually a bug. This is the first time we've ever demoed the new release of the system, and in fact, there's a bug there. Let me just file it directly in this way. Usually, you can just point to the file box in the browser, and it'll file it in there automatically for you. Let's not. Let me. All cards have a title, which is again determined entirely by the user. Doesn't mean anything to the system. Let me call this Soviet complaint. Okay. So what I've done is file it away, and I could have filed it in multiple file boxes so that under Soviet complaint and US TNF missiles, I could find this particular note card about the Soviets' belief about Pershing II. Let me go on, since things aren't going so well here. Would you pull back just slightly? And show you down here in this Soviet complaint card, the last sentence says the Soviets believe that Pershing II can reach Moscow, which is 1,500 miles away. And I want to know if that's true. While I'm processing this note card, I want to judge if it's true. So the thing I want to do is, I know I have a map somewhere in the system that shows all of the missile ranges of the Pershing IIs in Europe. So my problem, again, is to find that map. I could look through the index, I could look through the table, through the file box hierarchy, but in this case, I'm going to use note card search facilities, if I can search and create a search card. Did I hit search? And the search card says what I want to search for. I want to search through all the cards for the cards with the string map in them, and we see there are 2 of them. And if I, it creates a text card with the pointers to the hits, and you'll see that the result is a map of Western Europe, which is just an instance of the. Let me just get rid of the card now that I'm done with it. An instance of the Xerox Nullis text editor built onto a map database. And you see plastered around Europe are link icons that point to cards. So for example, if I go down here near Sicily, I can hit this link icon, and it will bring up a related note card, something about Sicily. And if I go over here near Britain, I'm sure I'll get a note card about something about the GLCMs based in Sicily. So it's very much like the functionality you find in FileVision, although we were there first, where you can lay out links two-dimensionally in a drawing. Okay, why don't you pull back so I can see. I'm running low on time, so let me just show you the final. What Ken basically did was he took these notes for several months. He then, he had about 500 notes, and he said, well, I'm not familiar with these notes anymore, and I don't like my organizational hierarchy, the one I showed you before. So he took all the notes out of that filebox hierarchy and reorganized them into a new filebox hierarchy that looked more like the paper he wanted to write. Once he'd done that, he created an outline for his paper we don't have any outlining facilities, so basically he translated that tree into a standard text editor, a card that was just a big instantiation of the text editor. And from that text editor, he wrote his paper. From that outline, he wrote his paper. And let me just show you the final instance of the paper that he wrote, because it's an interesting document in its own. This is the paper, it's about 25 pages, and this is the section on weapon characteristics. Every time he referred to a note card in his paper in the system, he put a footnote pointer to that note card. So you see here are two footnote pointers, two footnote links. So if I press the footnote link, it'll reach in and bring up the related note card, which happens to be something about the speed of the Pershing 2. From here, I can follow the link to related note cards. Or, let me just, there's a secret way I can get at a link that points to the source of this note card. So if I press for the source link up there at the top, you see I can point back to the bibliographic reference for the source of that note card. So ideally that in turn would be electronic text which I could follow out to its related sources and so on. So from this final document I can spread out through the network and see how he built the document and what information he was using and what related information there was. Okay, let me just end this little demo here. Could you pull back so I can see the world again? Further back. All right. All right. Very good. This has nothing to do with Ken's paper. I'm going to talk about this a little bit later, but this is an example of what you can do in note cards. This was a new kind of note card created by Steve Bagley as part of a project on training people to fix photocopiers, and it's in fact an animation note card, and instead of having text or graphics, it's a little animation that when you bring note cards on the screen, it starts running, and it's part of a computer-assisted instruction package. So just wanted to show you that there are other kind of note cards besides boring text and graphics note cards. Let that run again. All right. Every official Xerox talk I give in this auditorium, something happens to my machine. Next. Okay. Back on to safer ground here. As I said before, we were very interested in building a system that was tailorable, that could adapt to the changing needs of the community and the individual users as they go through their task. And our initial solution to that was to build a note cards programmer's interface that has two components. There are 100 well-documented list functions that provide a programmatic interface to all the functionality in note cards. So anything plus more that you can do from the user interface, you can do from this programmatic interface, so people can build systems that use note cards as a back end or front end or whatnot. Then there's a new protocol for defining new types of note cards. I showed you the animation cards, which was defined by one of our users using that protocol. We've created video cards, which play a video scene on another screen. Action cards are the neatest. When you bug the link to an action card, it carries out an action rather than bringing anything up on the screen. And the card itself contains the procedure for that action. Okay. Basically, what we've done is allowed users to tailor note cards to particular tasks or users, and allow system designers to embed note cards in some larger systems. So we have this kind of dream that is starting to happen, is that note cards is built, I should have mentioned this a long time ago, inside the Xerox Lisp environment, sometimes called InterList D. And there's a core note cards around which is this programmer's interface that allows users extensions to note cards. And with a programmer's interface, we want to allow a whole range of different things. We want to change how the system looks to the end user in case you want to specialize the system for dentist's office or lawyer's offices or something like that. We also want to be able to have note cards be a back end or front end to, say, some AI expert, an expert system or what have you, or that we want to put note cards onto a database engine like Oracle to improve the underlying file structure or whatnot. So the idea is that note cards being embedded in this Lisp environment allows you to build systems around it. To show you that's actually possible, this is a project called IDE, which is Tom Moran and a number of other people are doing in our laboratory to build a system to help build intelligent computer system instructions. And this is a layer on top of note cards. Each one of these things is a specialized note card that when it comes up, it lays itself into the appropriate column determined by what kind of card it is. There are principal cards, rationale cards, and decision cards. And they've layered this whole system, which is probably just as big of note cards, on top of note cards using the programmer's interface. Okay, so that gives you a small idea of what you can do with the programmer's interface, and we've been fairly successful in providing users with the ability to build systems on top of note cards. Let me switch now and talk a little bit about the note cards user community. Building a community of users was an explicit research goal of this project. When we set out, we didn't want to be another PARC system that was good for 15-minute demos and good for nothing else thereafter. And we felt to build a real system, we needed feedback from real users to guide the design. We had in mind a community of 15 users in our own laboratory. The current user community is really a success disaster, to use John Brown's words. There are between 50 and 100 Notecards users. I think it's probably even higher than that. And several big systems built on top of Notecards. Plus, Notecards has made its way to, I don't know, 50 university industrial sites. So we're getting bug reports and feature requests from all of these sites all at once, and it's become a little more than a research project to support this user community. But the user community provides us with some really important things. First of all, being a lot of us are psychologists or pretend to be, it gives us an opportunity to study Notecards users and uses. And Lissa Monti, for example, has been with us for the last few years studying people using Notecards and various aspects of that. It gives us a library of hacks and sample structures, things people do to improve the system a little bit and make it available to other users. It provides us with bug reports and feature requests. I don't know if that's positive or negative. It provides us lots of enhancements, adapting Notecards to specific tasks, for example, projects that adapt Notecards specifically to the lawyer's task, or a project that adapts Notecards to helping design photocopier parts and so on. Okay, so there's this library or growing enhancements to the system. And finally, and most importantly, it gives us the beginnings of a self-supported user culture with war stories and wizards and educational processes and so on. And that inside of that user culture is a lot of very important information about what the system is good for and where the system has to be improved and so on. So you can learn a lot by observing that user culture. Okay, what have people in what have people used Notecards for? This is a very short sampling of some of the interesting applications. This is probably a little bit old, but let me go through it. First of all, perhaps the biggest use is for information management and organization. Sort of a personal information base where people store and organize their papers, their mail notes, their clippings, their addresses, their notes to themselves, little doodles and so on. They all kind of throw it in Notecards. Similarly, for project management, a number of projects at Xerox Special Information System are all organized around a giant note file where they manage the paperwork, the schedules, and so on, the personnel on the project. There are a few people who have used Notecards to manage information for competitive analysis. So, for example, down in Pasadena, there's a very large secret application for all this that keeps track of all the spacecraft ever put into space and our knowledge about them and pictures of them and so on. Similarly, someone else did an analysis of commercial expert system and kept each expert system inside of a separate note card and linked the related note cards together and so on. Okay. A second major use is for the general area of idea processing, analysis, argumentation, and idea structuring. Something I'll talk about in a minute. Kurt Van Lane used the system for competitive argumentation sort of as a workbench for analyzing competing theories of how children learn procedures. And I'll show you that in a minute. We have a number of lawyers using the system for legal research and authoring. George Cole, who works with us here as a computer science student who used to be a lawyer, is using the system to write a brief on the liability of AI. Programs. Down in Pasadena, there are a number of lawyers using the system to kind of represent legal briefs. So we've had a number of people using it for that. Engineering design, we've had a few people out in Rochester at Xerox RBG there using Notecards as kind of a workbench for keeping analyses, failure analyses and functional analyses as they design copier parts. And finally, there are these systems built on top of Notecards. The one I talked about, IDE, which is a system for the design, development, delivery of intelligent computer system instructions. So that's kind of a range of the kind of uses we have for Notecards. Let me just show you what I think is one of the cleverest use of note cards. And this was created by Kurt Van Langen when he was in our lab. He's now at the psychology department at CMU. Kurt took his PhD thesis, 328 pages, and encoded it into note cards. It was about 900 note cards, and it took him 10 days to do that. And it had an initial structure. Kurt's thesis was amazingly structured. It wasn't one of these nice rambling theses, but it had a beautiful structure, and it was very easy to translate into a network structure in note cards. So in Kurt's thesis, there were 20 issues, and each one of them was represented by an issue card. And each of the 20 issues had 3 to 7 hypotheses that were competing for explaining that issue. Okay, so each one of those was represented in a hypothesis card. And the whole goal of this task was to choose one of those hypotheses as the winner. So one of those hypotheses here is double-starred. It had a winner link between the issue and the hypothesis. The rest had loser links or competitor links. I forgot exactly what you call them. From each hypothesis, there were a set of arguments that said this hypothesis was true or false. So there were pro arguments, there were con arguments, and there were moot arguments. And each one of them was represented by an argument card and connected to the hypothesis card by a pro, con, or moot link. And then finally, each argument was supported, supposedly, by a bunch of facts about the world, which were experimental results and so on. Okay. Now, Kurt put his thesis into that form in note cards. So there's this giant, basically, tree structure of note cards. And one thing he did was, his idea was that these 20 issues in his thesis were actually connected. Okay, so they were all interrelated. And he drew a browser starting at the very top node in his hierarchy and said, show me my whole world. Well, it turned out to be very small, about yay big. And what he realized that was he had a set of islands in his thesis, and they weren't actually connected together, so he couldn't draw a large tree structure of his entire thesis. So he spent several months actually using note cards to help him put in the links between the various issues in his thesis that he knew were there, but not actually represented in the thesis. So that's one way in which note cards actually helped him. But this tree structure really didn't help him with his original task, which was to compare these hypotheses, because the arguments and the facts for those hypotheses were actually too spread out in this tree structure. So he created a new type of note card, which is actually very clever, and we used it in a number of applications since, which is called a matrix summary card. A matrix summary card is a matrix of links. Across the top is a set of facts. Okay, these are links to cards which are facts, and if I point them, I get a fact about the world. The children do such and such according to such and such an experiment. Okay, down the side are links to a set of hypotheses. Okay, so if I press competitor hypothesis once, I bring up a card which is a description of some hypothesis about the world. And in the cells of this matrix are pointers to argument cards. So basically, if I point to this link here, you see it's a plus link. That means it's a positive argument, and it says that this fact supports this competitor hypothesis. Similarly here, this fact 1 is negative toward this competitor hypothesis 2, and there's a little argument card that actually goes on and on about exactly why he's making that argument. Okay, so from this matrix summary card, he can figure out which one is actually the winner hypothesis by looking at the number of pluses and minuses and zeros, which means it's a moot argument, or the hypothesis has nothing to do with the fact. Okay, one of the interesting things he actually discovered here was that when he filled out a matrix card for each one of his 20 issues in his thesis, most of the cells in these matrices were blank. In other words, in his thesis, all he argued was what was the winner hypothesis, and he didn't actually argue against the competitor hypotheses. And when he went back through note cards and filled out each one of these cells, he actually found some winners which became losers, and losers which became winners, and so on. So by redisplaying the information instead of a tree structure in its matrix structure, it was really helpful. Nice example of idea processing in note cards. Just to show you I'm not making all this up, this is a screen slide from Kurt's note file. Here's the matrix card for some issue called test patterns ? Here's the card describing the feature about the world, which is we find overspecific test bugs in some cases. Here's one of the hypotheses he has, and here's this little argument that's explaining this hypothesis is supported by this feature. So that's a very nice example of note cards in use. Good. Let me now switch to an assessment. We've had, in addition to Ken, 50 50 other users on the system. We've been able to watch them using the system for a whole wide range of tasks. We've been able to get a good idea of what the system is good for and where it needs improvements. And I want to go through some of the major issues, I think, where we stand in understanding how to build and how to use systems like Notecards. So let me start with this notion of information management. Again, most people use Notecards to keep their stuff in some sort of manageable form, in some sort of manageable organization. And so usage patterns suggest that Notecards are a very useful tool for this notion, for information management and organization. And I sat down one time to think about why that was the case. And these are the kind of things that make Notecards unique. I don't think any one of them makes Notecards stand out from, say, the Unix directory structure, but taken in conjunction, they make Notecards and systems like it to be a very useful tool. First of all, it provides a uniform interface to a whole variety of different types of informations, ranging from text to animations to procedures. To bring up an animation in Notecards, you point to the link, just the same as if you want to bring up a text card or whatnot. You don't have to call a different utility to bring up your sketch than your text and so on. Second, Notecards provides navigational direct manipulation object-oriented interface to both information and to the structure of that information. So if you have a large note file that, containing a complicated network, you can edit that network from a browser overview, and you can directly manipulate the structure of the information without actually editing the information itself. Extensibility, when people don't like how the system works, they put in a little hack. They customize a procedure to find the cards. I have, for example, a Rolodex, and I type in someone's name, and their Rolodex card appears on the screen. I just did that because I use the Rolodex a lot. You can add new types of information, like we've added the video cards and the animation cards. Another important point is that Notecards is very good at handling very small scraps of information. Computer file systems tend to be bad at this. That you have to very inefficient at handling a note to yourself, a one word or one line idea. Notecards is very good at managing small scraps of information. And finally, you can organize the information you have in many different ways. So you can create multiple alternative file box hierarchies or different networks that represent different views onto the information. Again, hard to do. So I think the conjunction of these features make this an ideal information management tool. It's missing one big thing. You can't ask any questions of Notecards. The only way to find your way to information is to wander around this network or recurse down the file box tree. You can't really say, give me all the cards that have this property. So Notecards really needs query and search facilities. I think that's true of all systems of this nature, all these kind of hypertext-based systems. And I think there's a very interesting research question as to how you build query and search facilities into a system like Notecards. Running. We built the system not to do information management, although, as I said, it was one of our goals because we thought it was important in the original task. We really built it to do idea processing, for people to play with and analyze their ideas, to represent them on the screen and see how they relate together and so on. There are a handful of very successful examples of this. Kurt Van Laan's is one of them. I showed you that. And there are a number of other ones. But I think most users find representing their ideas in Notecards to be a very difficult task. And it's sort of curious that we built this system to help people formulate their ideas, but they find it hard to formulate their ideas in Notecards. And I'd like to take a little look at some reasons why that might be the case. One reason it might be the case is because we built a bad system. That Notecards is actually not a good system for supporting idea processing tasks. I'll talk about that a little bit. Another interesting problem is that there are tasks that may not really require the power and the cost that goes along with that power of using Notecards. And I think that's a lot of reasons people, their boss tells them to use Notecards. It's a neat, whizzy thing in our lab, so they use it for tasks for which it really isn't appropriate. And then they complain that it's hard to use. And finally, playing with your ideas is just a very hard task. And nothing we can do in building a system will get rid of that. So let me look at each one of those reasons. So just a wee bit closer. Isn't Notecards, in fact, a bad system for supporting idea processing? Well, I think the successful users show this is not the case. But on the other hand, I don't think Notecards is perfect. It's a fairly clumsy system to use in many ways. And getting rid of some of that clumsiness may actually get rid of some of the difficulty people have in using it to play with their ideas. One of our biggest problems is is displaying very large or complex information structures. Those browser graphs, you didn't get all that great of a demo. It's sometimes hard to see. The browser graphs can get very large. They're not unusual to have 200-300 nodes in those browser graphs, 10 or 15 of which you can see on your screen at any one time. And so to move around that browser graph, you have to scroll this very small window over a very large space. And Notecards lacks tools for displaying and manipulating these very large and very complex information structures. George Cole, who's our lawyer, has walls plastered with browser graphs printed out that are 5 sheets by 5 sheets, so 25 printed sheets, browser graphs, and you have to print them out and display them on your wall in order to be able to use them. So there's no way to do that in Notecards, and it's definitely would be improved by building tools to move around very large information structures. Another thing which I think is a little more intriguing and a little bit more built into Notecards, and that is that nodes and links are not enough of a representation in order to deal with a lot of tasks. And I think the biggest lack in Notecards is that there's no way to manipulate aggregates of cards and links. If I have a set of cards and links that, say, represents a part in a copier, and it has subpart links and cost links and so on coming out of it, I can't point to that whole substructure and say, that's part number 65. I mean, I can use the root node to represent the structure underneath it, but I can't pick up the whole structure at once and move it somewhere or replicate it. And we're starting to build a little of that in, but it's a real interesting question is how you build into hypertext systems this notion of aggregates of cards and links. There's a corresponding problem to that is that we have this structure called a card, and there is no internal structure to that card that's common throughout the system. I mean, there's text in text cards and circles and sketch cards and moving bitmaps and animation cards, but there's no way you can build a general system that says how many parts in that card and can I take part 37. So there's no common structure underneath that. And I think that all reflects in making it hard to use the system to represent tasks where you want to talk about aggregates or where you want to sometimes think of an object as a whole and sometimes think of it as a collection of parts. And there's anybody interested, a real interesting research question on how to put that in. Look at when is idea structuring needed, when are systems like Notecards needed, basically. I mean, representing ideas takes time and effort. Putting things in the Notecards takes, and really building a nice network structure with interesting links and interesting relations between cards and so on takes time and effort. And for many, many tasks, the overhead may not be worth it. It's just too easy to do it in your head. Whenever I start out to write one of these talks, I start creating this marvelous note card structure, and about 10 minutes into it, I said, oh, forget it, and I keep everything in one giant text note card and do the whole set of slides inside of one note card. It's just not worth the effort to organize your talk, which I have a good idea ahead of time inside of using note cards to do that. Well, when is all this power of note cards useful? Well, when your task is very large. I think that's why Kurt Van Lane did it, because he had lots, 900 note cards that he had to deal with. And so if he had a complex task, and note cards was a good way to handle that complexity. Well-structured tasks like organization charts, note cards doesn't have that much cost to use because it's easy to use. Collaborative tasks where you have to explicitly represent the ideas for communication is another good application of note cards. Evolving and discovery tasks where you want to keep a record of the structures you're creating. And any task where it might be processed by machine. So there are places where note cards, it is very useful, all the power of note cards, but you have to be careful to apply it in the right place because the cost of using the system may be greater than you need. Finally, let me just say, playing with ideas is a hard task. Building representations is just very hard. You have some ideas in your head or some ideas in a book, and you want to build them into the node and link representation language of note cards. The most frequent request from our users is a manual telling them how to do that. They don't really want a manual telling them how to. They want a strategy manual. If you have this task, this is how so-and-so did it. Okay? So there's really crying need to kind of guide people in how to represent their ideas in a system like note cards. One of the interesting things is that we're putting that task of representing your ideas or representing information, representing data in the hands of the every user of note cards. In many systems, that's the task of a professional. So if you're a corporation and have a lot of data, you go out and hire a professional database designer who takes that data and represents it in the data language of the system, and then the users use the already represented information. We're taking that task and taking it away from the professional and giving it to the average user, and that's just hard. All right, we move on here. Another dimension in which we can assess note cards is how well it supports collaborative work. This is not something we believed when we started out, but we certainly learned it quickly. Collaboration between two or more individuals is the norm for most idea processing tasks, especially in a lab like ours. People don't work alone. They share information, they work on coordinated group projects, they co-author papers, and so on. Well, Notecards is terrible at doing this. First of all, two users can't simultaneously access a note file, so you have to do draft passing of large note files. Users tend to get lost in networks created by someone else. So someone creates a giant network and hands it off to their co-author, and they, what is this? In fact, that's very common where you consider your earlier self, your collaborator. You go back into a note file you created 6 months ago, and what does a contradiction link mean after all? And there are very few tools in Notecards to make any of this easy, to make sharing or collaborative work easy. Things like there's no versioning, no layering. We can't create separate layers and merge our changes into the system. There are no guided paths of the network that say, hey, look down this path because it'll be interesting. There's no differentiation of individual contributions. So if you and I build a note file together, we'll have no idea who created what and so on. Let me just show you. This is a note file that Randy Trigg and Lucy Suchman are using together in our lab to try out collaboration in Notecards. And they do it by draft passing. One person uses the note file and then says, I'm done through the mail, and the other person copies it to their machine and so on. Elaborate token passing here going on in order to share this note file. Some of the features here, they felt it necessary that you had to figure out who contributed what comment to the note file. So this is probably very hard to see, but when Randy uses it, he types in Helvetica 10-point font. And when Lucy uses it, she types Times Roman 12-point font. And when they're sitting together at the note file, they type in Helvetica 12-point font. Okay? So they're doing kind of bootstrapping contribution tracking, so they know who said what in the note file. In addition, for example, anytime anybody makes a change, they put a note in the note file use history, and they create a card like this one here, which contains all the information about what they did in that instantiation of using the system. So they're trying to build some tools without actually building tools that help. And that actually this year has been a big piece of our work on Notecards, is to make Notecards better at collaboration. And there are really two aspects to that. One is to understand collaboration, the other is to build some widgets. And so in terms of building widgets, I think here I called it technology. We built distributed note cards. Basically, we've changed note cards so that you can have simultaneous access to simultaneously shared access to a note file from anywhere on a network of machines. So it's a real distributed system. That is up and running in my office, and Randy and I have used it. In fact, I wrote this whole talk off the Notecard server, but it's not really ready for general access. Hopefully in 6 months it'll be in use in ISAL, and people keep all their information on a Notecard server instead of on these IFSs. The other part of the project is to understand collaboration. Lucy and Randy are doing in-depth interviews and other ways of analyzing collaborators in our lab to understand collaboration. And we're also looking at what kind of things you have to, I've called it social interface issues, but how do you put in the coordinating things about collaboration into note cards? So things like history cards, contribution tracking. They don't really want a manual telling them how to, they want a strategy manual. If you have this task, this is how so-and-so did it, okay? So there's really crying need to kind of guide people in how to represent their ideas in a system like Notecards. One of the interesting things is that we're putting that task of representing your ideas or representing information, representing data in the hands of the every user of Notecards. In many systems, that's the task of a professional. So if you're a corporation and have a lot of data, you go out and hire a professional database designer who takes that data and represents it in the data language of the system, and then the users use the already represented information. We're taking that task and taking it away from the professional and giving it to the average user, and that's just hard. All right, move on here. Another dimension in which we can assess Notecards is how well it supports collaborative work. This is not something we believed when we started out, but we certainly learned it quickly. Collaboration between two or more individuals is the norm for most idea processing tasks, especially in a lab like ours. People don't work alone. They share information, they work on coordinated group projects, they co-author papers, and so on. Well, Notecards is terrible at doing this. First of all, two users can't simultaneously access a note file, so you have to do draft passing of large note files. Users tend to get lost in networks created by someone else. So someone creates a giant network and hands it off to their co-author, and they, what is this? In fact, that's very common where you consider your earlier self, your collaborator. You go back into a note file you created 6 months ago, and what does a contradiction link mean after all? And there are very few tools in Notecards to make any of this easy, to make sharing or collaborative work easy. Things like there's no versioning, no layering. We can't create separate layers and merge our changes into the system. There are no guided paths of the network that say, hey, look down this path because it'll be interesting. There's no differentiation of individual contributions. So if you and I build a note file together, we'll have no idea who created what and so on. Let me just show you. This is a note file that Randy Trigg and Lucy Suchman are using together in our lab to try out collaboration in Notecards. And they do it by draft passing. One person uses the note file and then says, I'm done through the mail, and the other person copies it to their machine and so on. Elaborate token passing here going on in order to share this note file. Some of the features here, they felt it necessary that you had to figure out who contributed what comment to the note file. So this is probably very hard to see, but when Randy uses it, he types in Helvetica 10-point font. And when Lucy uses it, she types Times Roman 12-point font. And when they're sitting together at the note file, they type in Helvetica 12-point font. Okay? So they're doing kind of bootstrapping contribution tracking, so they know who said what in the note file. In addition, for example, anytime anybody makes a change, they put a note in the note file use history, and they create a card like this one here, which contains all the information about what they did in that instantiation of using the system. So they're trying to build some tools without actually building tools that help. And that actually this year has been a big piece of our work on Notecards, is to make Notecards better at collaboration. And there are really two aspects to that. One is to understand collaboration, the other is to build some widgets. And so in terms of building widgets, I think here I called it technology. We built distributed Notecards. Basically, we've changed Notecards so that you can have simultaneous access to simultaneously shared access to a note file from anywhere on a network of machines. So it's a real distributed system. That is up and running in my office, and Randy and I have used it. In fact, I wrote this whole talk off the Notecard server, but it's not really ready for general access. Hopefully in 6 months it'll be in use in ISL, and people keep all their information on a Notecard server instead of on these IFSs. The other part of the project is to understand collaboration. Lucy and Randy are doing in-depth interviews and other ways of analyzing collaborators in our lab to understand collaboration. And we're also looking at what kind of things you have to, I've called it social interface issues, but how do you put in the coordinating things about collaboration into note cards? So things like history cards, contribution tracking, chat cards that allow people who are simultaneously using a note file just to speak to each other and so on. Okay, so we want to look at how we build those things into note cards. Okay. Let me go on to another topic, which is near and dear to our hearts. That's tailorability and extensibility. We built note cards to be an extensible system. And I think the programmer's interface has been reasonably successful in giving list packers the ability to change the system, to specialize note cards for their specific task or to build large systems on top of it. Where we really haven't concentrated and is very important is to give note cards tailorability to the average user. Okay, most of our users don't program in Lisp. At least most of the people outside of our lab use note cards don't program in Lisp. They don't program at all. And how do you give them the tailorability and adaptability of the system without having them program? And we've been thinking, big research project here, interesting one. A lot of simple things you can do, give them millions of parameters. Well, we've done that in note cards. You can allow them to define macros. A little more interesting is this notion of structures and templates. You know, people want a strategy manual telling them how to represent their ideas. Well, one way to get that across is to give them templates that say, you know, here's a set of pre-constructed network that kind of helps you analyze a legal brief. So we've been looking at this notion of templates and template generators or languages for describing templates, which you can then give to people. Also, we're looking at rule systems built on top of note cards. Part of the IDE project is looking at building a rule system on top of note cards that manipulates automatically. You can write rules to manipulate note cards objects. So basically, we're just looking at this notion of note cards tailorability. So, okay, I'm running a little over here, so let me just terminate by giving an advertisement to what is going on in note cards. Randy and Tom were interested in letting the world know exactly what they're working on now so that people who are interested can get in contact with them. So the current research supporting collaboration is probably the biggest area we're working on right now. The rest, linguistic analysis for indexing and retrieval. Part of the problem in building queries and search into note cards is trying to get queries that are based on the content of note cards rather than, say, the structure of the note file or strings inside of them. So in our lab, we're working on linguistic analysis for indexing and retrieval from note files and from document databases in general. Tailorability for non-programmers, I've already talked about. Extensible tools for visual network browsing. Again, how do you make browsing these very large networks and note cards easy and fast and facile and so on. Cross-note file linking. Right now, if you create several note files, you can't link across them, and that's a critical piece of technology or piece of widgetry that a lot of users ask. For example, the fellow who's here from Harvard has graduate students representing various ancient Greek plays in note cards, and the plays refer to each other, but each play is in a different note file, and they can't refer to each other directly. And if you had cross-file links, you could be able to do that. Management of inconsistent information. Basically, that boils down to building truth maintenance into note cards. Some of the ideas to put some automated reasoning tools into note cards. And finally, unstructured idea generation. The idea there is note cards tends to be hard to use when you're brainstorming. And that's because you have this tendency you have a stream of ideas coming out of your head, and you think you should put every idea in a separate note card, which is a mistake to think that, but people tend to think that. And how do you help people get their ideas out faster in note cards and then allow that to move smoothly into a note cards representation with separate ideas in separate note cards and so on. Okay, so that ends my talk, and I'll take questions and do demos closer up in case you missed. Oh, the screen doesn't work. Yes, Sarah?
On your slide, you implied that one of the things that could happen or that could be considered is note cards as a front end to a database, a more standard traditional database. And I wondered if you'd comment on that a little more, particularly in light of the fact that note cards really doesn't allow any query and search mechanisms.
Yeah, I mentioned that we're thinking of note cards as a front end to a database. And how did that fit in with the fact that note cards doesn't allow any query and search? When we think about note cards as a front end to a database, we're actually thinking of the database as helping us do a lot of, well, there are two aspects of the database. One is databases do file management. And if you noticed on that slide of participants, nobody was a computer scientist there. Randy has a degree in AI, but nobody was a real computer scientist. So if you look at if you look at file management and storage management and stuff like that in note cards, it's just terrible. And one of the ideas of using a database was just that it would take care of that junk for us. The other idea was that relational databases are good at things like searches and queries. Hypertext databases like note cards are good at navigational access. And the question is, how do you take those two strengths and merge them into one system? Now, I don't have any answer for that question, but one of the things we've been thinking about, for example, is you want to take a note card and you want to register it in the database. So you say, here's a note card and it has these properties, okay? Like it has these keywords and it has a color red and so on. And then when a person can ask questions of the database in order to access individual note cards. Now, we came across that very strongly in a project we did where we, master's student Steve Levy worked with me, build a system that sorted your mail automatically into note cards. Okay, and we built, every time there was a new author, we called it author, person who sent the mail, we created a file box for that author and made a link to the card, right? And we had dates. So you had a file box with dates and you made a link to the card, right? And we had distribution lists. So every distribution list in the whole world, there was a card and a link to it. Well, Steve insisted that was the way to do it. I thought it was patently absurd. I mean, this was a very good example where a good relational, in fact, not even a relational, DBase 2 would have done for us, right? Where we could have taken each mail card and registered it into this relational database and used that to do the search by author and so on, okay? But there's another interesting research question, in case anyone's looking for interesting research questions, to merge those two navigational hypertext-based systems and these kind of nice query-based systems. Yeah?
I wonder if anybody has done something in continuation of Kurt Van Leeuwen stuff. I'm thinking of some rhetorical structure theory that man has, and so you could actually describe in the language for the possible reads, like walking and whatever, with grammar, and
yes.
that would be useful in linearizing the text or
yes.
filling up more general ways.
Yes. What? Yes. Well, let's see. Can I repeat the question?
Basically, rhetorical structure
right.
theory of
Yes, I know. That's what I'm trying to think of a nice summary of the question. Has anybody thought of extending Kurt Van Leeuwen's work into looking at rhetorical structures and representing rhetorical structures inside of note cards, and using the rhetorical structures for interesting tasks like linearizing text from a network? Yes, we've thought a lot about it. I didn't talk much about it today, but a whole big portion of the note cards research has been in the notion of argumentation and how you support argumentation. How do you help people form better arguments? And Susan Newman, who's been working with us, looking at, she took Ken Allen's paper and kind of analyzed the rhetorical structure of it and used it to represented the rhetorical structure as a set of note cards. We followed up on Ken's, Kurt Van Leeuwen's notion of this kind of matrix-based analysis, and we took a book called, Kathy Marshall at Xerox Special Information Systems, she took a book called Essence of Decision, which basically talks about the Cuban Missile Crisis, in this very similar notion that there's this decision matrix where you have options and you have goals, and you want to kind of analyze how your options and goals lead to a decision in this case, in the Cuban Missile Crisis. So she represented that in note cards. And then underneath the note cards, she had goals and options, and then as in Kurt's thing, each cell in the matrix pointed off to an argument that said this option supports this goal. And underneath that, she had a very complex evidentiary structure. Okay, so she said evidence has this, if I want to support this goal in such and such a way, I have to have these kinds of links coming out of it and so on. So people are beginning to build, kind of templates for particular kinds of arguments in note cards. I mean, there's no, let me say it this way, we're thinking a lot about that subject. It's very interesting, and note cards is a very good task for that. But as of now, I can't say we have any real, easily explained simple results or anything like that from that. But they're good examples. Kathy Marshall, for example, wrote up her structure she was doing on the Cuban Missile Crisis as a paper, which, yeah.
At the beginning of your talk, you put up a slide of the component processes that were going into idea processing, and you had a big hole. And you said you were trying to fill that hole. And I wonder if you'd comment on whether you think that, aside from an information management system with some really neat features, whether you've done much about the hole you were trying to fill.
Yeah, I mean, I think Kurt Van Leeuwen, the example I showed you, is a very, belongs directly in that, is a task directly in that hole. He had a bunch of ideas, concepts he wanted to deal with. He wanted to analyze the structure, the relationship among those ideas in alternative ways. And note cards made it very easy for him to do that. Allowed him to create the tree structure that represented his ideas in one way. It allowed him to create the matrix structures, which represented his ideas in another way. And it allowed him in the same breath to compare the two of them. And now Kurt's is not the only example. The Cuban Missile note file. So there are a number of examples where note cards has actually been an ideal tool for helping them doing exactly the kind of idea processing that I was suggesting up there. Now, another good example is George Cole, who's been writing his legal briefs, is analyzing the liability of AI programs and note cards, playing with alternative structures for the legal brief that he's writing, and so on. So I think we filled that hole, and part of my assessment was to figure out exactly how well we filled that hole. But we have at least certainly partially filled that hole. Yeah.
In that vein, in your use of a second ago of use of the word brainstorming, how well does note cards support doodling?
Well, note cards doesn't support doodling very well at all. The editors underlying note cards allow you to doodle. And basically, you know, if you want to doodle, you bring up the sketch note card, which is kind of a structured drawing editor. You can doodle in that. Or if you doodle textually, you bring up a text note card and you doodle in the text. The real question to ask is how you get from there to a more formal representation of your ideas. And note cards doesn't help you a lot in that regard. So some of the things we've been thinking about is, you know, you want to doodle and you want to change your, you know, you finally figured out exactly what the structure is in a sketch. And you want to say, aha, make that sketch into a bunch of note cards where each box is a separate note card. There are note tools to help you do that. There's a tendency, creating a note card involves a lot of overhead. First of all, it involves segmenting the stream of ideas or information you have, so you got to figure out exactly where you want the note card to start and end. It involves titling the note card. It involves putting the note card into a file box. Okay, and all of that makes casual use or doodling hard. Okay, so the best way to use the system doodle is just create one card and put all your junk in there, and then you have the problem of translating it into structures. Okay, anybody want more questions? Come up.